and boom. All right, sweet. So now we are on percents. So let's see what this is all about. Answer in your own words. Would you rather use a coupon worth $20 off your entire purchase, or would you rather use 20% off your entire purchase? What do you guys think?
20%.
20%.
Why?
You only get $2 off, $20.
The more you spend, the more is the discount.
There you go. So like, let's say we spent $500 and like, oh, you get 20 bucks off, or you get 20% off. You're definitely going to go with the 20%, right? So good. So 20% is more of a discount. That's what I'll write here. That's fun. Makes us think. Discount. Make sure I can spell. Okay, cool. Suppose someone leaves a $20 tip on a $200 check. Uh-oh. Maybe this will get people going. What do you guys think? Good tip or bad tip?
A horrible tip.
How much percent of a tip is this?
10.
10%. So we said a bad tip. So, and it is
Yes.
10% of $200. Then even go leave 15%, right? My goodness. Okay. If you think it's a bad tip, what would be a better tip?
The 15%, the minimum, $30.
15%. Let's have fun with this. What do you guys say? 15% for good service or just service in general?
Just
I
service.
think that's 15% is like the
30%,
lowest generally.
We'll just say just for service. What do you guys think about 20% tips?
I think that'd be like a good service. And then 25 or like 23 would be like, okay, very good.
All right, all right. I like it. What do you guys think about that?
I think that's fair.
All right. It varies, right? All right. So there you go. So at least we know what a good tip is and a bad tip is. All right. Cool. Hey, that was fun. All right. Now we actually get into some math, huh? What's up?
Some don't even deserve a bad tip.
some deserve no tip.
Yes.
We got to be nice right now, though. Restaurants it's hard to find servers and it's hard to get good service. So got to be nice out there and be patient.
Yeah, somebody might spit in your food.
Yeah. All right. So now the fun part's over and more fun begins. We actually get into the math of things. So we want to write these sentences as equations and solve them. So we want to translate English into algebra. So before we begin, let's label what some words mean. So what is going to mean a number, right? What is a number? Or we can even say, what is our variable x? It's an unknown number. And then is, I shouldn't put it equal, I'll say what means those. And if you see the word is, it means equals. It's telling us how to set up the equation. And if you see the word of, it represents multiplication. So these will help us translate English into algebra. So for number 3, it says what is 35% of 200? What algebraic equation could I write for this?
0.35 times 200.
Good. Well, we're missing one piece to it because remember, we can do stuff non-algebraically, but of course we want to put it into an algebraic context. So when we say what is, so this first part, what is, we're saying x equals, and then now what you just said, 0.35 times 200. So that's how we translate English into algebra. What is 35% of 200? So X equals 0.35 times 200. And remember, guys, whenever you multiply by percent, you must always convert them into what?
Decimal.
Decimals. Good. So what is 35% of 200?
70.
70. Good. So that equals 70. All right. Perfect. Number 4. 35 is what percent of 200? So what's a good equation to write for this? It's giving it away already. 35.
35 equals
Equals X.
200x.
X. Yeah.
Good. So 35 equals 200x. So what percent of 200 means X times 200, or we write it as 35 equals 200x. Okay. And now we have to solve our own equation. So to solve for X, you will divide by what number?
35.
To solve for X,
200.
divide by 200, because that'll get X by itself. So you'll divide by 200. And what is 35 divided by 200?
0.175.
0.175. Oops. Oh yeah, I can leave that there. That's good. So we can say X equals 0.175, but we want our answer in percent. So how many places should we move our decimal to the right?
2.
2. 1, 2, and we'll get 17.5%. So 35 is 17.5% of 200. Okay, how we doing, guys?
Hanging in there.
I'll always move them 2 places, or
Always, yeah,
Okay.
because remember, whenever you change a decimal into percent, you are technically multiplying it by 100. So you always multiply it by 100.
Okay, yeah.
And how many zeros are in 100?
2.
2. So you move it 2 decimal places. All right. 5. 25 is 40% of what? So for number 5, you'll have 25 is, and what do we write for the next part?
0.40x.
0.40x. 25 is 40% of what? So 40.40x. Okay. And then divide by
0.4.
0.4. And x equals
62.5.
62.5. Good. All right. So 25 is 40% of 62.5. Okay. Cool. 6. 15% of a number is 19.5. Calculate that number. All right. So how do we write this equation?
15.5 equals 0.15x. Was it the other way around?
No, I think you got it right. So I'll show you the way you said it. So 0.15x is 19.5. You said 19.5 equals 0.15x. Same exact thing. So either way you want to go. Okay. And now all you have to do is divide by
15.
15.
0.15. And x equals.
Sarah, I'm so sorry. I'm a
What's
little bit confused. So you said we could write it either way. So it'd be 19.5x or
No, it would still be,
equals 15x.
yeah, it would be
Or
19.5 equals 0.15x. And the
Okay,
process would still be the same. If you divide it by 0.15, we would still be here.
okay, gotcha. Thank you so much.
Yeah. So 15% of 130 is 19.5. Okay. Number 7, 35 is 15% of what value? How do we write this one? There's the 35 is.
equals 0.15x.
That's it. 35 is 15% of what value? Hey, this is like the one above it, right? And now you just divide by 0.15. And what is 35 divided by 0.15?
$233.3 repeating.
Good. 233.3. We'll just say 33. We can even put the repeating on there. Why not? All right. And those are, well, not all the percents, but that was the first page. So everybody good with that first page? All right. And also that was good practice in translating English into algebra. Yes, I know we don't need algebra for everything. You can probably calculate these in your head, put them on a calculator, but it's also good to practice how to translate from English to algebra. So that's what we did on those examples. Okay, now number 8. 30% of all students at NVC transfer to UTSA. Of these transfer students, 12% are going to major in biology. If there are 15,435 students at NVC, how many will transfer to UTSA and major in biology? All right. So how do we set this one up?
Well, times 15,435.
Well, you have to think about what that would do. So if you did the 12% times the 15,000, that would just tell you how many biology majors are at NVC. We want to know how many biology majors are transferring to UTSA and majoring in biology.
You got an unknown there. 30%. Oh, okay, I see it.
So would we do like both percents, like separate both percents and then, hold on.
I guess one thing we could find out is how many are going to UTSA. What operation will we do there?
The 15,000 times 0.3, or yeah, 15,000 equals 0.3x.
Well, here we don't really, so for these ones, we don't really have to make an algebraic statement since we're just solving the word problem. So it would be 15,435 students. Those are all the students on campus. And we know how many are only going to UTSA.
30.
So we would multiply this by
30.
0.30. So how many students are going to UTSA?
4,630.5.
So 4,630.5. Now, what we're saying in this problem is that of this many students, how many are going to major in biology?
Multiply the
you
4,000 by 0.12. Right?
Good. Multiply what by 0.12?
4,000 by 0.12. The new number that we just got.
4,635 times 0.12. And now this will give us the number of how many students are transfer students and going to major in biology. And what is that number?
555.66.
555.66, which we can round up to how many students?
556.
556 students.
Are these notes going to be posted on Canvas?
These ones that we're doing right now, probably not. I like to post them when they're finished, but remember, you can always access them through my OneNote link. And I'll show you that towards the end of class again,
Gotcha.
how to access that. Okay. So number 9 is just like number 8. This says 30% of all students at MVC transfer to UTSA. Of these transfer students, 12% are going to major in biology. What percent of NVC students are going to be at UTSA and major in biology? So we know that,
556.
well, that's students. Is 556 a percent though?
No. So you divide it by 12.12.
If you divide that by 0.12, guess what we get?
Try out.
We get 4,000 back.
Okay.
So
Divide it.
all this question wants to know is, what is the percent? So what percent does 556 students make?
We divide the 4,000 by the 500 students, right?
So you're almost there. If you're dividing the 4,000, then you're dividing the transfer students that are also not majoring biology. We
Oh, okay.
specifically only want the students majoring biology.
Hey,
Don't think too hard.
it's gonna be 4,633.3.
No, we don't want that, because remember, we're looking for a percent. We're not looking for an actual number of students. We just want a percent.
So
And there's 2 ways to get there.
you have to move the decimal, maybe?
So how many students are transferring? What percent?
12.
30% or transfer?
30. Yeah.
30%.
Yeah.
Come on, Penn. There we go. 30% are transferring.
So then do we divide the percent that are transferred, oh, never mind. I don't know what I'm talking about.
No, say it. What were we gonna say?
I was thinking dividing the original 15,000 by the 556 students.
Yes.
Oh, it is? Okay.
Yes, you got it. Yes. So that is okay. I'll erase this for now. I'll erase that. So all it wants is the percent. So we know that 556 students will transfer from UTSA and major in biology. That is 556 students out of the 15,000 students. So all we have to do is take our 556 and divide it by 15,435. And what does that give me?
27.76.
3.
Like 27% or 28%.
Try it again. Try it
Oh,
again.
I did the other way. Never mind. God.
At 0.036, and then if you move the percent over twice, it'd be like 3.6%.
There you go. Glorious. That's all
Glorious
it's looking
purpose.
for. That's it. Let me read my box a little better. Ooh, that was rough, huh?
You telling me?
The other way to get it is, guess what? How many overall students are transferring?
30%.
And how many are majoring in biology?
6.
500.
12%. I said that last time and I was wrong, so I didn't want to say anything.
12%. What is 0.30 times 0.12, y'all?
Oh, the 3.6, right?
Yeah, 0.036.
So why would we even do it the other way? Like,
Because
that just seems more confusing.
it works either way. Because remember, whenever you say a number out of another one, it's also giving you a percent. Like, what can we talk? Like basketball, you shot 8 free throws out of 10. What's your percentage of free throws made? So that's what we did for this first part, right? But another cool way to go about it is like, hey, 30% are transferring, and of those, 12% are majoring in biology. Why not multiply those decimals numbers together and get the same answer?
Okay, thank you.
Crazy, right?
I know, I was like,
Okay. What is it? 807. So yeah, we'll stop at this number 10 then. Okay. So number 10, it says, in a Gallup poll of 976 adults, 68 said they drink alcohol every day. What is the percentage of respondents who said they have a drink every day? So what type of setup would we use here? It's kind of like what you did in number 9.
68 divided by, or 976 divided by 68.
Other way,
That'd
like
be
you
it.
had it. Other way, like you said.
68 divided, or 68 over 99. I can't.
There you go. Because that's how many adults out of the 976 adults, 68 said they drink alcohol every day. And now you do 68 divided by 976, and what do you get?
Oh, that's not right.
0.069. Or wouldn't you round it
Yeah.
up? 6.
Let's go out to 1, 2, 3, 4. Let's go out to 4 decimal places. So 0, 6, 9, 6. Let's try that. And now move the decimal over
2 places.
2 places. And what percent of those adults say they have a drink every day?
6.96.
6.96%. And there was a 7 after this, so it could also be considered 6.97%. 68 said they drink alcohol every day. The others are liars.
You know, that's like triple time over there. What is that now?
There you go. All right. And there we go. And that's where we will stop for today. So let me stop recording.
I got a question.
Yes, go ahead.
We just leave it like, 6.96, or do we have an option of rounding it off or leaving it just the way it is?
For percentages, I would say two decimal spaces max. So like that 6.96 is perfect. If you wanted to round, because you could round this all the way up to 7%. But I believe having more decimal places is just, the more decimal places you have, the truer the number is.
Okay.
So,
Take problem.
okay.